Lewis structures. Lewis structures are also called Lewis dot diagrams because, as you can see from the examples here, you're putting dots around the symbol for the element. These dots represent how many valence electrons an atom has. And what I want you to remember is what valence electrons are. Valence electrons are the outermost electrons on an atom. So we're not talking about all of an atom's electrons, just the outermost ones. For example, let me show you this picture again from your reading of argon. Argon here has a total of 18 electrons, just like it has 18 protons. 2 in the first level, 8 in the next, and 8 in the outer level. These outer 8 are called the valence electrons. So if I were doing the Lewis dot diagram of the electrons for argon, I would put 8 dots around it. Notice you have argon on your paper, so you'll end up with 8 dots. Where these dots go is important. They go around the outside, but not just in a circle. They actually kind of make a box. So notice 2 go across on the top, 2 go across on the bottom, 2 go up and down on the left, and 2 go up and down on the right. So that when you're done, you end up with kind of a box shape. Now in your reading, there are examples of Lewis dot diagrams. Let me pull these up here. So notice when you get 8 electrons around an atom, 8 valence electrons, you have 2 across on top, 2 across on bottom, 2 on the left, 2 on the right, going up and down. When you do these, I'd like you to do them in this order. Put the first electron here, the second electron here, third and fourth, so that you have 1 in each spot before you make them pair up. So then 5, 6, 7, 8. So notice when you do barium, there are 2 valence electrons, and so you'd put 1 here and 1 here, 1 and 2, 1 and 2. Now how are you going to figure out how many valence electrons each one has? The way you know this is based on the periodic table. The periodic table shows you the different group numbers up at the top, and this rule is going to work for groups 1 and 2 and 13 through 18. Groups 1 and 2 right here only have 1 digit in them. The digit is 1 for group 1, so they all have 1 valence electron. Group 2 will all have 2 valence electrons. Group 13 ends in the digit 3, so the last digit tells me the number of valence electrons, so group 13 will all have 3 valence electrons. Those are the outer ones, remember. Group 14 has 4, 15 5, 16 6, 17 7, and 18 would have 8 valence electrons. So as you do these, all you need to do is put the correct number of dots for each one. There is an exception here. Don't forget that helium is element number 2, so it only has 2 electrons total, so it can't have the 8 valence electrons that it should have for group 18. Again, depending on how many valence electrons each one has determined by its group, you're going to put that many dots around the outside. Do them in this order. You won't always do it this way, but for this exercise I'd like you to practice doing it the professional way, but it's really the way that scientists would prefer it if you were doing it correctly. Do them in this order: 1, 2, 3, 4, then 5, 6, 7, 8. Fill all of these in that way, get all of the electrons for each one, and if you still have questions, please ask.